Okay. Sweet. All right. I gotta go here and get changed.
Slide off in the.
Yeah, that's a good picture actually.
Yeah, we felt this picture was a little bit better than the other one, and we updated it.
Okay, good.
What we're gonna do is we're kind of using Guido's computer to present, but like what we're gonna do is we're gonna use Kalen's phone to record the robot when it gets to that point. Because we have the bit to demonstrate the robot, because you know we have the video, but you wanted us to demonstrate it, so we're gonna have Kalen join this meeting and show the robot moving.
Okay, well, yeah, that's fine. That's fine. You can demonstrate it also. That's fine. Yeah.
Yeah.
Okay.
All right. Well, we start again?
I guess.
Did you have the video, right? Did you do this on the video like I told you?
The video is at the end of the presentation.
Let me get this straight. It actually works?
Yeah.
Yeah.
So
I'm proud of you guys. I'm proud of you guys. I'm so proud. I'm so proud.
Okay.
Okay. You want us to go ahead and start?
Yeah, please go ahead and start.
Don't forget your.
Oh, the slide. Yeah. Let's move some of these chairs real quick. Yeah. And angle that up a little bit. Cool.
Where did that name go? No, Garrett.
That doesn't matter. If you guys want to come,
Yeah, we can just
stand up here for the intro.
Let's start.
All right. So,
Hold on, is everybody recording this?
Oh,
I
recording,
don't
yeah.
Don't
see
think
it
so.
active.
No, it's recording. It's recording.
Oh yeah.
Oh, it is.
Yeah, it is.
Yes, it is. Okay.
Okay.
Yeah, it's recording. Okay.
All right. I'm Noah Grigsby, and this is my team.
I'm Garrett Chisnall.
I'm Guido Marsile.
I'm Kalen Berry.
I am the project leader for our senior Capstone project, which is the design of a mobile robot controlled over, I guess, a cellular network. We kind of modified the project and are now controlling it over Wi-Fi. But as you'll see later, we'll explain some of that. So let's see.
Down button.
This is project objectives. Okay, so as you can see in the project objectives, we were kind of tasked with building a mobile robot with ground mobility, which we have achieved that. We also have been able to achieve the controllability and communication via the Wi-Fi network. And the other objective we had was the ability to carry a payload, which we have achieved that as well. And it can carry a payload of up to 50 pounds.
Our response and the goal was in this project to build an unmanned surface robot capable of carrying a payload. And like Garrett said, the payload's it carries up to 50 pounds. Our robot will also be controlled remotely using Wi-Fi technology. The advantages of our robot, long range communication and multi-terrain.
You want to go over that timeline?
The project timeline, so in the spring, we came up with the design and we just pretty much was getting the nitty gritty of the robot. And as you can see, we started on February 11th and then the follow-up was March 4th. We got more detailed within our design presentation on April 2nd. And the final detail and presentation was April 16th. Fall 20 this semester, we had the assembly complete by September 28th. The programming complete and the robot testing complete by November 17th.
So this is just a basic SolidWorks drawing of our pretty much the robot base. It doesn't have any of the hardware on it, but our built one does, just for the drawing. But as you can see, it's the base is composed of omnidirectional wheels, 4 12-volt DC motors, some L brackets, and then we used screws and nuts and stuff to put it together. This is an engineering drawing showing the dimensions in millimeters within the design. And then we have our bill of materials.
Yeah, so starting with the bill of materials right here, we've updated it since our last time we had our presentation with you guys, since our project has been slightly modified since then. As you can see, we have our sim hat with the GMS, such as going to be used for cellular communication, but as we stated before, we've modified our robot to be communicatable with Wi-Fi. So we had our SIM card as well. We have our motor drive controller for the 4 motors on the robot, our Raspberry Pi 4, which is the heart of our robot. We also have the robot kit, which is the base plate and all the other things that comes with it. And our main power source, which is our 26,000 milliamp hour battery.
So here we have our updated power requirements since last time. Based on all the parts we used, total power consumption was at about 75 watts if everything is running simultaneously at full power. We used a service factor based on recommendations from our professor of about 1.3 to accommodate power consumption that we couldn't account for due to error. And then we doubled that number because we don't want to run the battery dry. We want to only run it down to about 50% each time to make the length of the battery last longer. Maximum voltage used in the system is 12 volts because of the motors. We calculated the current by taking our new total power and dividing it by the max voltage possible. And that came out to about 16.25 amps. And then we did the calculation in order to make this battery last about 1 hour and to go down to 50%. It came out to about 16,250 milliamp hours. The reason we went with the 26,000 milliamp hour battery is it was one of the only batteries we found that could output 12 and 5 volts simultaneously, so we didn't have to use a converter. So that's why we did that. Here's an electrical schematic. It's actually pretty much a modification of last year's project that was done by Navarre's team, but we edited it to accommodate our project. So as you can see, we have our 26,000 milliamp hour battery that outputs 12 and 5 volts. The 5 volts leads to the Raspberry Pi, and then the 12 volts is routed to the motor drive, which distributes that 12 volts to each motor. And then we have some technical specs.
So here are our technical specifications, and likewise to the bill of materials. This has been updated since our last presentation. This is just going to be a more kind of specific look at what parts we have on our robot. So as you can see right here, we have our 4G GPS module, which this module right here with our SIM card was going to be compatible with the network Verizon. That's who we had chosen to communicate with and have them be our mobile controller for the robot, but that has since changed. Moving on from that, we have our Raspberry Pi 4. And then from then on, we have our lithium ion battery. And then from then on, we have our 4-wheel motor drive controller. From there, we have our DC motors that have come with our robot kit. And then finally, we have our robot kit. And then next, we'll talk about the pseudocode.
So this is pretty much, this is our flow chart. So it shows the basic outline of the program that we used for the robot. So you would start the program. Well, first of all, you'd start the robot, establish a connection between one device and the robot, so an SSH. So we open a shell, and then it establishes a connection, and then you can choose to go through directories and then execute the program with Python through the terminal. And then this is a flow chart that pretty much shows the menu for our, howdy. But this is pretty much a flow chart that shows the menu options on how to control the robot. So the way I coded it is that it displays this menu to you when you execute the program so that you know what you can do instead of having to guess. And then the operator makes input, and then you get an output. And then we have a video here that Guido's going to launch.
Yeah, I'll go ahead and play you guys this video. This is a video that myself and I had the help of my roommate film this video. So here's going to be our demonstration video for the robot. Let me know if you guys can see this. Can you guys see it playing?
Yeah, good.
What is that?
So yeah, there you have it.
And that was our video. Moving on. No,
No, don't play it again.
Need to figure out how to move. There we go. Yeah.
All right, so yeah, that was the video. So this is what we would just kind of consider for future project teams if they wanted to take what we've done and maybe enhance it a little bit. It'd be great if they, another group could potentially waterproof the robot and then potentially give it mobility in the water. Adding a camera would be great because it could work well with sensors and be able to detect obstacles in its path, and the camera would help with viewing those things, or if anyone just wanted to be able to monitor the robot in case it got stuck somewhere, they'd be able to find it, and then potentially adding GPS technology with it as well. So when you are controlling it from a distance, you can have a better idea of where exactly the robot is located.
Oh yeah. So this is pretty much a very basic model of a potential future project with SIM card communication. We were not able to accomplish this goal due to quite a few difficulties with it and a lot of lack of experience. But the idea is that you could maybe either make an app or some program on your phone and communicate with a cell phone tower that would route the communication towards the robot. But like another method you could do would like actually just send text messages and have a program in the robot understand text messages to accomplish the same goal that we did with a secure shell. And then this is pretty much a few different angles of our final product. Powered on and connected. You can see the I/O block, motor drive, Raspberry Pi, battery, etc. We did utilize quite a bit of Velcro. That is a very good tool for connecting a robot together. So, do we have any questions?
Okay, well, thank you, guys. So you told me that you're going to demonstrate it now.
Yes.
Yes. Kalen's joining in right now, or he just did join in, and we'll have you guys seeing the demonstration shortly. And Dr. Capilano has since joined us as well.
Let me switch the camera. Oh. There we go.
Okay. 1 second.
I'll mute mine real quick.
Yeah.
Okay, so where's Kalen? Where is he right now?
Right here.
Kalen is
We're in the building.
Kalen is 213. You're all 213.
Yeah, there you go. Why is it doing that?
I don't know.
No, it's still doing
This is, yeah.
They're gonna step out into the hallway to demonstrate it for you guys.
Oh.
It's just interference moving. So.
Okay. Control that. You see it on your camera?
Yeah.
Okay.
Okay. All right. Thank you. So
That's good, y'all.
Yeah, that's good, y'all.
Okay. Sweet.
Okay,
And I
thanks.
guess, I guess now we can return back to our last slide. Do you guys have any questions for us?
Yeah, so again, so were you guys able to connect it to a different router, or they have to be on the same router?
So the robot itself has to be on the same network. So the Raspberry Pi, when it connects to the network, as long as the mobile device that's controlling the robot is connected to the same network, then as far as like, for instance, if you're in a company and that network is across the whole place, then you can control it via that one mobile device or multiple, whichever one's connected to the Pi and the network.
Okay. All right, so there's actually, I have a point. So you mentioned that it can carry a payload of 50 pounds.
Yes.
Are you guys sure of that?
That information is only based on a rating from the kit. So on the website, I think we bought it from like Alibaba.com. It's rated to carry 20 kilograms. But because we don't have a payload for it, there would have to be testing in the future. Like if a group was instructed to make like a 20 kilogram payload to mount to it, that'd have to be, I guess, tested.
Okay. Yeah, I think, I mean, I don't know. Is it like only like on horizontal surfaces or like on inclined surface? I think on inclined surface, probably it will not be able to.
Probably not on an incline. I'd have.
Well, you have 12-watt motors.
Yeah.
Say, that's 48 watts. I'm not
Yeah.
sure actually if 48 watts can carry 50 pounds, on inclined surface. But probably
Yeah.
it'll be, it'll be able on a horizontal surface. Okay.
Right.
Move it on a horizontal surface.
And I think with a potentially upgradable option could be different sets of wheels for different terrains. For instance, we have the Mechatronic wheels right now, but they have sort of a slipperier material on them. But for instance, if you were to upgrade to maybe a rubberized material or an off-road type wheel, you could traverse more, maybe steeper inclines, even with the payload on it. But I think with the current wheel setup we have, it would slip and slide everywhere.
Yeah, and more powerful motors if you needed to carry anything big.
Okay. And so, by the way, so right now you have set up the program so that it can do how many instructions, how many functionalities?
See, it can do
left, right, and
you do
left.
forward, backward, lateral right, lateral left, rotate right, rotate left, and then stop. So I think that's
slow, fast.
oh, and then low, medium, high speed.
11.
So that's 11, and then there's an exit function to end the program. So technically 12. So,
Okay.
yeah.
So okay, 12. All right. So and by the way, the speed for controlling the speed, what did you do?
What we did for controlling the speed is that this motor drive is capable of pulse width modulation.
Okay.
And so with the help of Dr. Kaplanoglu, he explained to me that these companies that make these devices have proprietary code that you can find. So I was able to find like on GitHub their proprietary code on how to set up the pulse width modulation. And so I used their base codes and then I used their demo code and then I redid the demo code to make it do what we wanted it to.
So you didn't do your own program, but you used the one that pre-exists, right?
Yeah, the one program that I did on my own was the thing that actually controls its directions and speeds. But everything before that like the pulse width modulation code was pretty much already done.
And was it, by the way, a separate pin? There's a special pin that you have to set up to output the pulse width modulation, or not?
Yeah, so it's in a separate Python document. So like it's saved as a Python file. But so like .py. But what you can do is when you're writing code, you can import other codes by using the import.
What I mean is there a specific pin that has to be used, or did you use any pin?
I think it uses a specific one. Yeah.
A specific one.
Yeah.
I mean, you have to use that specific pin on the Raspberry Pi.
I guess it could be used on a pin that is capable of pulse width modulation. So I don't know how many pins on the Pi are capable of it, but I know that the code that establish it, like gives it the ability to have pulse width modulation is based on some.
Okay. So actually, a last question. So for the card, the GSM card, so what was the difficulty with using it?
So the main issue is that the device was supposed to be compatible with any 4G LTE network, including Verizon. We bought a 4G LTE card from Verizon, like one that you could just pay like for a month or whatever. And the Verizon didn't it couldn't identify, it was incompatible, even though it was supposed to be. And because of that issue, we weren't able to really ever get it connected to Wi-Fi in the first place. We thought we were getting there, but it really never worked out. I think further research showed that you can use maybe Cricket or and maybe AT&T. But if you go on those websites, you can enter the I think it's the IMEI ID and test compatibility, but it's pretty confusing, especially with a lack of experience in that field. I thought it would be way more simpler than that, and it was quite a challenging task. And then the second part of it would have been if we had ever been able to establish a connection, and then we'd have to figure out how to code it to make the robot understand SMS text messages or some other serial communication function. But it was I think we would have been able to accomplish that if we had had more coding experience as a team.
Okay. That's good actually, good comment. Thanks. We can actually, I mean, for that in the future, look at that actually. So for the video, so guys, I don't have yet. So did you upload the video, by the way?
Yes, the video is in our drive, but I have to, if you want me to submit it on Canvas, then I will submit the file for the video itself on Canvas.
All right. Okay. Yeah. So I'll open it again. But it's a little too large. I think it was 7 gigabytes.
Yeah, I think it's a little too. What I can do.
You can save it as a link, like put it in the Word document and save the link.
Yeah, what I can do is I can send you, because the YouTube video that we had encrypted or embedded into our presentation is a non-public video, so that video will always be able to be viewable by whoever. So I can send you the YouTube link, and that way you have access to that video 24/7.
Okay, so no, I know. I want actually the original video.
The dot move.
Okay.
I want the original video.
Okay, I can pull it off my computer, and then I think what I can do is I can upload it to Google Drive and then share it with you, and that'll give you access to the original file.
Okay, what you can do, you can open it on there's a Windows movie. I'm sorry, Windows. The movie player.
Mm-hmm.
You can move it, then you can open it, then you can compress it.
Okay.
You can actually make it smaller in size.
Since it's dot move, you'll probably be able to
I
do
don't remember how, but I mean, there is a way you can actually just make it smaller in size to bring it down like to 10% or something.
Sure.
Okay.
Okay. Yep, I can do that.
Do we have any more questions, Dr. Nassab?
Yes. How many hours do you have?
As many as you need, sir.
Okay. So I'm not talking, I don't have any questions about the technical issues. I just want to talk about the overall, the way the project is done or
Yes.
presented. I would have liked to see the project requirement or definition first. Like,
Okay.
what did the customer want? Okay. So somebody told us to design the thing that does this and that, and this kind of payload capability, this kind of range, this kind of weight. So basically all the constraints.
Okay.
So it's like, that was the job that was given to us. So that was it's probably in your report and all that, but you did not present that, or you did not start with that.
Yeah.
So you always start with, okay, this is the task that was given to us, okay? And it may not be the exact thing that you finish up with, but during the presentation, you can explain why you had some design changes. For
Okay.
example, let's say the customer says, we need this to have a payload capacity of 50 pounds. And then you can say, well, we could not do that because the other constraint of budget, for example, kind of conflicts with that. If you want 50 pounds, it has to be more expensive. So you can kind of justify that.
Okay.
So that was kind of a main thing missing, that, what was the job? What was the task? We just started with, okay, this is what we did, but we didn't start with what we're asked of you, okay?
Yeah.
So that at the end you can see that, okay, did we finish the job? Did we kind of only did part of it and the next group has to do the rest of it, or why we changed it, and so forth, okay?
Yeah, that makes a lot of sense.
So that's one part. And the other part was the design process. So you basically showed this is what we did, but you did not show the reasons for why you did what you did, okay? So why you picked Raspberry Pi, why you picked that size wheels, why you picked a certain communication protocol, So
Yeah.
I'm sure you had a lot of reasons for doing everything, but you did not present it. So the design process was missing as the reasons for everything that you did, okay? I mean, you mentioned some of them. For example, well, we picked this battery size because it gave us 12 volt and 5 volt, so those are good reasons. But that has to be kind of also the same thing for everything else that you have there.
Yeah.
From dimensions to power to communication style to basically everything that you have picked, you have to have a reason why you picked that.
Even if it's a simple reason like budget or.
Yes, yes,
Yeah.
simple
Yeah, that
reason.
makes sense.
And sometimes it's just as simple as this is what's available,
Yeah.
So, but there is a reason, and so it may be a very trivial reason, but so there should be a reason. And sometimes it's more complicated than that, that you did these calculations, whether it's a force or velocity or power or control schemes or something, and based on these calculations and reasoning and logic, we picked this, and we had 3 options, and we picked this option 1 or 2 because it had this advantage and this other advantage and this other disadvantage and so forth, okay?
Yeah. Okay.
So that whole thinking process was missing in the presentation. You basically presented, this is what we have done, but all the background in what was asked and how we came up with this, what were the reasons for, what we did, were kind of missing. So that's really an important part of it. The other thing that we really need to make sure we do is that you need to hand this off to the next group in a very organized way. That means, let's say you all left today and we never heard of you, right? You just left to another country or something, right?
Yeah.
So we need to have the robot, the code, the instructions, everything that next person just can walk into the room and read something and redo what you have done, and in a matter of an hour or so, and get the robot working. Okay.
Yeah.
Because sometimes students leave and we don't know where the code is. We don't know how it works. There are a lot of missing instructions. So every one of these projects, we want them to have very detailed instructions of, how you start this from scratch, basically. Here's the code, you install it on your phone. These are, the sample codes that, sample instructions or sample commands that you can use. And here's a video of, how it works, whatever it is, so that someone without calling you or communicating with you could pick that up and move forward.
Yeah.
So just make sure you leave all that. Because if you don't, you may not get a grade, you know.
Actually, that's thanks for mentioning that point. Yeah, I think you are guys missing. There's one document that is missing, which is how to operate document. You know, just press the button, turn that switch on, you know, and you know, so on. You know, the steps.
There should be a user manual because I submitted one.
It does not have. Does it have the
Okay.
steps?
So what you want to do is try it with someone. I mean, you all have, I don't know, maybe somebody you have roommates with or someone which is not in this group, and say, okay, here it is. Here's a user manual. Here's this thing. See if you can follow this. And the person, you know, of course, you need to pick the right person that's kind of technical enough that knows what some of these things are. But at the same time, it should not be part of your group, so
Yeah.
that somebody from outside of your group can follow the instructions. Then you will know whether the instructions are good or not. You know?
And
Yeah,
also,
but there should be in the user manual that I made and submitted, there's an operations section that goes from the beginning of how to establish the link all the way to controlling it.
No, I saw that, and that was good. It was actually a very good document. I'm
Yeah.
just saying that test it on someone.
Yeah, that makes perfect sense. I mean, because I've got one friend that's in like computer science here
Yeah.
at UTC,
Yeah.
maybe. And
Just
then
test it on, on that person, and then when they get into, you know, they don't know what to do, and they have to kind of figure it out. They say, okay, there's something missing because you're not supposed to be figuring it out. It should be all clear. You know? So then you will know what's missing if somebody else does that.
Yeah, that makes sense.
Okay. The other thing on some of the things I think Kalen was presenting that some of the features are kind of long range communication, multi-terrain, you know, payload of 50 pounds. You need to be more specific. That, for example, when you say long range, you know, what does that mean? You know,
Like a mileage or.
yeah, 10 feet, 20
up to
feet,
20
200
feet.
feet, you know.
Yeah,
So-
in our video, what we tried to portray was that Noah, when we were filming our video, Noah was in our lab right here in 213D, and where the robot was placed was out in the center courtyard of the EMCS, and that's where we were doing that. So we could have been a little bit more clear about where we were as far as distance-wise to the robot. And as previously stated before, you know, if it's on the same network in a massive company, for instance, like at an Amazon facility, as long as it's all together on one network, then it can be controlled over, you know, how many square feet or however many.
Yeah, it can be controlled
Thousands of
within the
yards.
network range.
Yeah, so you could mention that, because long range usually means that there is a signal and there is a receiver, and when you get out of the range, then you don't receive it, right?
Right.
As opposed to a network that's saying that wherever the network is, we are good. It doesn't matter where it is.
Mm-hmm.
So you need to be kind of a little specific, because in some cases where you have one receiver and one emitter, then the type of building, the number of walls you have to go through and all that makes a big difference. And that's what some of these rescue robots have to deal with, because they go into buildings that, you know, the robot is being controlled from outside. And depending on what the building is made of and how many rooms they have to go through, you may lose communication, as opposed to this one that's relying on the network that's everywhere. So, yeah, you need to be kind of more specific of what does long range mean, you know, when you say long range communication.
Okay.
If you say, okay, long range because you're basically saying it covers a large area as opposed to kind of a long range, right?
Yeah,
Right,
it'd be a large area, not like miles.
Just like, you know, a cell phone, you know, you have coverage in the whole country. It has nothing to do with the cell phone being long range, right? It just have coverage everywhere.
Mm-hmm.
Right. Okay, and we say multi-terrain, again, what does that mean? So what kind of terrains are we talking about? Are we just talking about vinyl floor and carpeting, or are we talking about rocks and water and, so, because when you're selling this to a customer and you say, this is a multi-terrain vehicle, and they're gonna say, well, what does that mean? What kind of terrains can this operate in? So
Right.
you can be a little more specific.
Okay.
One last thing on the battery sizing, not that it changes the outcome, but I think your reasoning may have been off a little bit. You came up with the 75 watts or something, then you added that service factor 1.3, came up with like 97 watts. Then kind of said, since we don't want the battery to run dry, we're going to multiply by 2. Well, that's not where you want to multiply by 2, because wattage is just how fast the battery is being used. Okay, so if you have use for 90 watts, the system is not going to use any more than that, just because you designed it for 200 watts. The system is going to use whatever the system uses. Where you multiply the 2 is at the end, where you have amp hours, and that's the life of the battery, right? That's the capacity of the battery. So when you get to the amp hours, you can just multiply by 2, then you get the same result. It's just that you multiplied it by 2 a little too early. You just had to like
That makes sense.
2 or 3 different lower steps.
Gotcha. Okay.
Okay, and that's all I had. I think that was a great project. You just need to frame it correctly. You say, okay, this is what the customer wanted. This is what we did. These are the reasons why we did what we did. And you can, at the end, kind of conclude that this is how close we came to the customer's specifications or requirements. And if there was any changes, you have justification for that.
Thank you so
Yeah,
much for
thank
your
you for the
feedback.
feedback. Yeah, that is actually very helpful.
Thanks, Dr. Nassab. So again, guys, I'm gonna open on Canvas to upload the video, the edited video, and I'm gonna ask you please to take off from YouTube, because I'm gonna put it through the classes YouTube channel. Okay. UTC Mechatronics. And with the edit, you added everything, right? I think you added everything. You put the everything.
Everything back.
Right. So yeah, please upload it. And there is actually one last document. I think it's probably we need it for the ABET visit, probably the lessons learned. Okay, the lessons learned document.
Okay.
Yeah, just like put what the lessons learned. For example, programming, design, engineering design, and so on. Okay, management and so on. And so please, yeah, have these the video and the lessons learned document. And then I'm gonna put the grade. Okay, after that, I'm gonna give you the grade. But generally, good work. Actually, just want to have a question. So actually, we're gonna have a student who's gonna teach, who's gonna give, training classes on programming, Arduino programming. So I think that will be very helpful for the next projects.
Yeah, that resource will be a great contributor for future projects.
Definitely.
I believe so.
Yeah. So I think that's actually good step. Well, my comment is you did, guys, a good job. I mean, you tried your best, actually, and that's the most important thing.
Oh, I have something you might want to, if this is recorded, that's fine. You have it. If not, you might want to write this down. In those lessons learned, there are 4 items that you need to specify or write about separately. So like a paragraph for each.
Okay.
So I'm going to mention those. So one is called lifelong learning. So what does that mean? It basically means that you learned how to learn on your own. You did not have to have a class to do something. For example, let's say you did the coding and all that, and you didn't have a class about it, but you now know how to learn on your own. So mention a few examples that we kind of did this, did that, and we didn't really have a strong background in that, but we learned it on our own. So on the lifelong learning, again, you want to kind of mention a few examples of things that you had to learn on your own, and you did that successfully. Okay, just one paragraph. And the next paragraph is team dynamics, basically saying how we worked as a team. So so you can say the way we did that was, and don't be just too sweet about it. Just say everything. For example, say we went through this process to pick a leader because of these features of that person and characteristics, and then we had to manage our time and the contributions this way. If we had any problems, any conflicts, this is how we solved it. And maybe even, put an example there that, one time one of the team members did not contribute because of some personal problems, and this is how we kind of resolved that situation. Okay, so again, say how you did it and give some kind of a example, a good example. Now the third one is safety issues. Talk about any safety features of your design that, okay, it could be as simple as like we picked round corners for the plate so they are not sharp, okay? All the way to any electrical safety issues that, we covered the high voltage areas, or we anything that's exposed to water or something of, we pick this so it's not too heavy, or whatever it is. So something safety issue. A lot of times we do these without knowing because we are so used to kind of making sure everything is safe. But you have to kind of look at them and say, okay, what are some safety things that we incorporated here, or at least thought about, so mention those, again, just a paragraph or so. And the last thing is, this is kind of a little awkward or sometimes not easily done, and that's the public and societal impact of your design. Okay, now sometimes people say, okay, what does that mean? But it could be very simple. For example, you could say that this project could help this kind of population to do this kind of thing. For example, a disabled person can use this for this task, or it would have an impact on rescue missions or something like that. So that you basically say, how does the general public would be able to use this to their advantage? So kind of explicitly mentioning that, as opposed to we just created this and you can use it for whatever you want. You basically mention it that this is how it can impact the society. This is how it can impact the lives of others. And I'm sure there are so many things you can write about it, but you need to specifically write that. Okay, so these 4 items in that lessons learned need to be there, and Dr. Tantawi would kind of look at it, comment on it. He needs to officially grade those also, but it could be just like satisfactory and unsatisfactory type of grade. It doesn't have to be a kind of a letter grade or something.
So is this
done
by one team, or is this like each person?
No, for the whole team.
Yeah, whole team. Yes, whole team. Yeah, we need to show our accreditation teams and all that we do require this from you, and we do check it, to see how you're doing, and we do give feedback. So yeah, make sure these items are included.
Thanks, Dr. Nassab. So let me just mention them again. I don't know if someone is writing. Okay. Yeah, so lifelong learning, team dynamics, safety features, public and social impact.
Okay.
Yep.
We got that.
Yeah, we got it.
All right, so I'll give you, I think the deadline to upload the grades is Thursday or Friday, actually. Okay. I think 15th, no, actually we still have until the 13th, I think, until the 13th, but so I'm gonna open on Canvas for you to upload these 2 things, okay?
Yes, sir.
the video, the modified video, and the lessons learned document.
Okay.
Yes, sir.
Right.
Oh, is lessons learned document is going to be a separate document and part of your final report?
We will make it a separate document.
A separate document, I was saying.
Okay, okay.
But if you want it to be like inside the report,
Yeah, inside a folder that has everything, right?
Okay. Yeah, we can do that
We can
too.
do that.
Okay.
So we need a folder that has everything. And because when we show these to other people, they're going to start with the final report first. And then they're just going to look at other things. So yeah, as long as they're all in the same place, they're not scattered, one folder for one group. And it has, okay, documents, presentations, videos, whatever, so that it's organized.
right?
All right.
All right, very good. Congratulations. Now, which of you are graduating? Are you all graduating?
All of us.
All of us.
Yes.
Yep.
Wow. Are you the only ones?
Not yet. I'm not grading for their
Finals.
Yeah.
Of course. I mean, they have courses with me too, and some of you are not doing so well.
Is it time to end this now?
Hey, just so y'all know, I still haven't graduated. So
There we go. Anyway, well, I need to go. Well, it was a great presentation. Again, congratulations.
Thank you for
Thank
your
you so much,
time.
Dr.
Thank
Nassab.
you.
Thank you.
Thank you so much, Dr. Nassab. Thanks, Navar, for attending. And thank you, gentlemen.
Thank you.
Yeah, thank you.
Thank you
Dr.
very much.
hey, whenever
That's it.
Dr. Nassab had asked y'all, where did you, get the idea for this and all that, you could have just said, we just copied Navar. Just kidding. You guys did good.
Thanks, man.
Yeah.
All right, guys. Well, have a good day. I'll see you then. Please, so leave the robot in the corner of the lab, and I'm coming actually and picking it up.
Okay. Sounds
Yeah.
good.
Sounds good.
Well, thank you so much. Thanks.
Thank you.
All right. Bye-bye. Bye.
Bye.
It's overweight.
So you guys just want to do it tonight?
We need to do a
Guys, what is your text SMS?
Yeah.